Hello everyone. So, from this module onwards we will be discussing about either sustainability tools and matrices from other domains or from the domain of product and service design itself, but with different kind of approaches. So, let us start about something that we will call as distributed economy. So, sustainable product service system design applied to distributed economy. So, in this module we will be discussing other design for sustainability tools and approaches. First will be SPSS applied to distributed economy, then we will have to architecture, then agriculture for cities and communities, and then finally about carbon footprint. So, in today's lecture we will first try to understand what is distributed economy, then understand the relationship between distributed economy and how can it bring sustainability. And then we will see how SPSS can be applied to distributed economy. So, in distributed economies it is regarded as a promising model of locally based sustainability. So, what it says is selective share of production distributed to regions where activities are organized in the form of small scale flexible units that are synergistically connected with each other. So, if you see in this particular definition, there are couple of key concepts. First is it's a share of production distribution. So, that is why I am calling it as a distributed economy, where the production activities are distributed, it is distributed in various regions. The distribution happens in a manner that production is small scale and it happens through flexible units, and all these units are connected to each other, synergistically connected with each other. So, this particular definition of distributed economy and the concept of distributed economy was coined by 3 researchers in 2005 through their paper called Distributed Economies, a New Engine for Innovation. It was introduced as a strategy to guide industrial development towards becoming more sustainable. If you are interested to know more about it, you can go through this paper, Distributed Economies, a New Engine for Innovation. So, now let us try to understand the difference between different types of economies. There are 3 types of economies. The first one is called as centralized economy. What it means is I will have a central hub and there will be others. So, these nodes that you can see at the corner, these can be some of my producers of components. So, say for example, there is a car manufacturer. So, the car manufacturing happens in a centralized manner. The car manufacturer will be at the center, will be doing all the assembly and manufacturing processes. They will have many suppliers. So, these are all these different suppliers over here who supply different components. For the same component, say for example, for the front glass, for that one component this car manufacturer can have multiple suppliers as well. So, in the centralized economy, the main company who is located at the hub is the largest company. They also have the largest amount of monopoly in terms of economic monopoly. They are more powerful than its nodes. It is possible that in a centralized economy I have one big player and one of its supplier is also a big player, but in the chain most of the other suppliers will be smaller players. So, next comes decentralized economies. So, in case of decentralized economies, you can see there are many different centers. So, there are many different centers. Say for example, a car manufacturing company, if it has its factories in different locations, that does not make it a decentralized activity, because it is still the same manufacturer. They can have their factory located in many different locations. But what this implies that certain production processes are happening at different locations. Say for example, the Amul model which we had discussed in our earlier lectures. The production of milk happens in a decentralized manner. So every household owns some number of cows or buffaloes, and so the production happens at the household level. Everybody brings their milk towards to a local collection center, and from the local collection center it goes for further processing to a more centralized location. Since the producers in this particular context are distributed, are spread over a large area, there is no fixed one place where this production happens. Hence, we call this as a centralized model. Then comes a distributed model. In case of a distributed model, you have very small units. So, that in decentralized model also, each of these can be small. But in the context of distributed, each of these entities, the nodes over here, they are way much more smaller, and the nodes are connected to each other. Not necessarily each and every node does the same function. Say for example, one particular node might be manufacturing something, another node might be responsible for knowledge production, another node responsible for transportation, but all the nodes are connected to each other and they have almost equal power. So, let us see some examples to make this whole thing more clear. So, the major difference between all these things comes in the system structure, in its scale, and the connections. So, in case of centralized, you have large scale production units. You have a hierarchical distribution network. So, there is somebody who is at a higher level and then there are others who are at lower level. Distribution happens from level 1 to level 2 to level 3. So, there is a hierarchical distribution network. There are many and distant end users. So, say for example, this car manufacturer of ours might be located in one part of the country, and through this hierarchical distribution network of distributing cars all over the country and maybe also globally, they are distributing their vehicles. So, they do have many end users and the end users are very distant. These end users can be business to business users or business to consumer users. Say for example, if the manufacturer is a manufacturer of trucks, then most likely they will have business to business customers. In case of cars, those cars can be also used by say a person who wants to start a car renting service. So, then in that case it becomes a business to business customer. In case it is sold to an individual customer who will use it for his or her own requirements and that of immediate family members, then it is a B2C customer. In case of decentralized, you have small scale production units again, which I call them as small scale because they are smaller scale than that of centralized units. They have a distribution network, but the hierarchy is small because the nature that you see in this particular diagram. Their end users are also located little bit more nearby than in the case of the centralized economy. In case of distributed network, you have again small scale production units. You can have standalone peer to peer connected to share resources or goods. So, these distributed, say for example, if I install a solar power station in my house, then I am doing energy production in my house. So, I am doing energy production in case my energy was produced by a thermal power plant or by a hydroelectric power plant. I am in the first category. I am using power generated by a centralized system. So, the power generation is happening in a centralized location in a particular area and is supplied to my house. In case I use a solar panel located in my house and I generate my own electricity and I use that electricity, I am going to the distributed model. Why? In this case, I am generating energy in a distributed manner. So, say for example, I own a solar panel in my house, my neighbor owns one in their house, and in my neighborhood, say there are 100 houses and every house owns one solar panel. to generate their electricity, but we are not connected to each other. So in case when when I'm not using that electricity which is being generated by my solar panel, it gets stored. So that's the context when everybody is doing distributed energy generation, and we are in a standalone mode. We are not connected to each other. But this system could have worked more efficiently if we were all connected to each other. So my surplus energy production could be used by someone else, again certain agreed upon payment modalities, of course. So as a result of this sharing, more efficient usage of the system is possible. In that case, what I call my system as peer to peer connected system. So we in this neighborhood of 100 houses, we are doing distributed energy and we are also connected to each other. So we are doing a peer to peer sharing model. Now say I cannot rely completely on solar power, because I think in my location or under the given load conditions that I require, solar energy will not be enough. So I can also be at the same time connected to the centralized grid system. So that's another context of distributed. The third one is they are located. So the major criteria of distributedness is determined because they are located by the end user. So the end user becomes the producer. Now they can be individuals, entrepreneurs or organizations. So say for example, if a company decides that we will run on solar power and they install solar power at their own location, so that can be also called as a distributed energy generation happening. Now you have to be careful that even in a distributed economy, certain activities can happen in a centralized or decentralized manner. Perfect distribution is only a theoretical concept. So what we can do is we can tend more and more towards distributedness, because if you see our network structure, this shows that almost all the nodes are have equal amount of power. The everybody in this network is connected to everyone else, and say for example a snap happens in this particular link, the whole economy will still survive because a new only that link broke down, every other link has still survived. But in actual context, this perfect distributedness is not possible. What we can do is we can tend towards being more and more distributed. So if I try to compare scale wise, the scale of centralized operations is way much bigger than that of decentralized, than that of distributed. So say for example, the operations of Pepsi can be called as centralized. So they have a centralized company, they might have their factories located in many different locations, but they are all owned by the same group. So it's a centralized manufacturing, and they have a hierarchical distribution network to distribute their products. They also have many suppliers who supply different items which are required to do the production of the drink as it is. Amul can be understood as an example of decentralized. So in this case, what is happening in a decentralized manner? Production of milk is happening in a decentralized manner. The company ownership is decentralized. So there is it's all the farmers who produce the milk, they are part of the cooperative, which is, and the cooperative is called as Amul. But their processing of milk and say production of value added products like butter and cheese and so on, they again happen in a centralized factory. So not necessarily in a decentralized system everything happens in a decentralized manner. Certain activities can still happen in a centralized manner or in a distributed manner. Similarly, even in a centralized organization, there might be some places where you can identify a degree of decentralization or distributedness. If you remember, we saw an example of a solar power generating service from Tanzania, which was called as Empower. So what was there? So if you want to recall about that particular case study, you can go to week 5 lecture 3, there we have discussed about this particular company's offering. So the SPSS offer model that they have is offering the they would offer the solar panel along with 2 bulbs, all the fixtures and a mobile charging unit. So all of these is the ownership of all these products is with the main company, which is Off Grid, and their service is called as Empower. So the ownership lies with the company itself. They come and install the whole unit in a particular consumer's household. So what I am doing over here is every household generates their own energy. So I have energy generation, electricity generation happening in a distributed manner. The payment happens by the mobile app, and the payment is on the basis of how much power you consume. The company Empower is responsible for maintenance of the solar panel, the bulbs, the fixtures and the mobile charging unit. So that was an example of distributed economy. What is distributed over here? In this particular case, maybe manufacturing of that solar unit is not happening in a distributed manner. The solar panels, the light fixtures, the bulbs, the mobile charger, they are most likely manufactured in a centralized system, but energy generation over here is happening in a distributed manner. At this moment, most of them are standalone distributed because 2 houses or 2 units are not connected to each other. They are standalone. So anybody who is interested, they have the unit and they generate their own power. They do not connect it to with their neighbor. So this distributed economy, and how can we design for distributed economy, how we can bring in sustainability, and our initial, as I told you, that we are trying to look on sustainable product service system design applied to DE. That is the hypothesis that is from the group Lensen 2018. So when I introduced this particular group to you, of which we are also part, so it's a learning and education network in sustainability. It's a group of, currently there are more than 150 universities from across the globe part of this particular initiative. So this is a developing area, and we are trying to develop case studies, theoretical theories on how to design, and also trying to develop pedagogy material. So according to this particular group, the definition of distributed economy is small scale production units located by or nearby the end users, whether local individuals, local entrepreneurs and or local institutions or organizations, that is the producers are the same end users or nearby them. So in the major concern of distributed economy is either the producer is the consumer, or the consumer is located very near to the producer, and these producers are all small scale production units. So if the small scale production units are connected with each other to share various forms of resources and or goods, these can be physical or knowledge based goods, like for example energy surplus in the context of our solar panel, they become a locally distributed economy network, which may in turn be connected with nearby similar networks. If properly designed, they are promising to promote locally based sustainability, that is sustainable distributed economies. So why can they bring in sustainability? We will discuss little bit more later, like how distributed economy has huge potential for sustainability. But before going into those slides, let's have a cursory discussion on that. So distributed economy, here you could see that I am trying to, rather than having centralized manufacturing, my production units are distributed over a large region. A centralized unit, because of its centralized strong hub, is very strong. So, they have much greater economic monopoly, they have much greater chances of power concentration, whereas in this case when these are all small units and connected to each other, there is lack of controlling power, all of them are equally powerful. So, brings in better development, each and every the chances that each and every individual can do more progress, more development is high. And if the system is designed appropriately, one can also have environmental benefits. So, socio-ethical benefit is ensured because of the fact that power distribution, manufacturing capability distribution is happening in a better manner, and if designed properly, we can also bring in environmental sustainability. Another important thing is, say in centralized economy, if I have to travel a long distance to reach my product from the hub to the final consumer, a lot of energy, a lot of pollution is caused due to the transportation service. But in case of distributedness, since the producer and the consumer is either the same or the consumer is located very near the producer, as a result there is huge savings in terms of energy required for transportation and in terms of pollution caused due to transportation. So, now let us look at different configurations of distributed economy. So, there can be 4 different configurations. Configuration 1 is standalone, I can have network, I can have networks of network, and I can have centralized connected distributed economy. Let us see what each of these mean. Before getting into what each of these means, what we have to also understand what is D in life cycle, and then we will see what each of these configurations have differences in the level of life cycle. So, when I am talking about D in distributed economy in life cycle, so life cycle of a product is product or services pre-production, production, transportation, use, and then finally disposal. So, now say in this particular chart, my outer circle represents distributed economy, my middle circle is for decentralized economy, and my smallest circle, central circle, is the centralized economy. So, now let us try to understand each of those configurations in the light of this particular life cycle. So, my example over here is a biogas plant. So, this particular biogas plant is connected to the toilet in a house. So, you can see the toilet unit and it is connected to the digester. When the biogas is formulated, it is connected to the house. So, what I am doing over here is, this biogas can be used for running a cooking stove and cooking food. So, it can become a substitute for LPG or a substitute for burning biomass based fuel, which is a normal occurrence in many parts of the country. So, now in case I have this kind of a unit at home, because my production is happening at my own home. So, my raw material production for fueling this biogas plant, it is happening at a individual house level. When the biogas is produced, the biogas is consumed at the individual household level. So, this is, and I am not connected to my neighbor. I have this unit at home and I am doing this production of fuel which can be used for cooking. So, my house 1 has a biogas unit, house 2 has a biogas unit. So, in my neighborhood, this is the structure. There are all these different houses with biogas units, but they are not connected to each other. So, this whole system is called as a standalone distributed economy. While because they are all standalone units, they are doing production of their gaseous fuel at their own houses. So, distributed economy, but they are not connected, so standalone. So, in this particular context, if I try to put it into the life cycle model, pre-production. So, pre-production in terms, say I want to construct that particular biogas unit. Again, the biogas unit is being constructed individually by each house. Either they might themselves construct the house with labor from their own family, or they might get in certain other laborers from the open labor market and get it installed in their location. Then also the raw material required for the running of the biogas plant is that raw material production also happens at that person's own household. So, I can say that all the pre-production activities are happening in a distributed manner. Biogas production, it is also happening in a distributed manner because it is happening in individual houses. Transportation, because it's from your biogas unit up to your own kitchen, or from your toilet to the biogas, the raw materials. So, there is no centralized transportation, neither it's a decent, it's again a distributed transportation. Use is also distributed, and disposal, when the slurry needs to be disposed of, the slurry can be appropriately treated, and then it can be used as a manure. Now, this manure can be either used by the family itself in their own garden or in their own farms, or they can be sold by them. So, the disposal is also happening in a distributed manner. Now, let us see an example of a network DE. So, it's the same biogas plant, say all my houses have the biogas. So, there is one big biogas unit. So, you can see the biogas unit is located somewhere over here. So, now the biogas unit is not located in every household. When you want to build a biogas unit in every household, optimizing the usage is a big problem, because you have to generate enough amount of raw material to run the biogas plant, and each house owning one biogas, you are consuming so much of material for construction of that biogas. Excess biogas, if produced in a particular house, it cannot be used in their kitchen. So, that is a waste. So, rather than having such kind of a standalone distributed economy, the standalone distributed economy of biogas does have certain environmental benefits, certain socio-economic benefits. But say in case I had a central unit with many houses, restaurants and shops connected to it, I can perform way much better on all the 3 parameters of sustainability. So, so this is called as a network DE. I have one big biogas plant which is shared by a couple of houses. So, the raw material from all these houses and maybe some restaurant and some nearby shops which are also connected to it come into the biogas plant, and then the biogas plant's biogas which is produced, it goes to each and every household. In this particular case, I will have to install certain metering units which will meter the input versus the output for a particular house or a restaurant, and then an appropriate payment structure has to be designed. Somebody has to take care of managing the biogas unit. Now, if I put it into the D life cycle wheel, you can see pre-production is still happening. So, pre-production, when I say that the raw material required for running the biogas plant, that pre-production of material is happening in a distributed manner in each individual household, shop or restaurant. Now, I can have a situation in which the biogas plant has been built collectively by this entire community. Then the ownership of the unit and the maintenance is also happening in a distributed manner. In case that is not the context, say there is another third party agency who says that okay, I will install it, I will run it for a certain payment. So, in that case, that particular part is happening in a centralized manner because of the that particular company. Now, say production, right, because there is one unit for many households, I can say it is somewhere between so I can say that it is a centralized production system, but it is not like the other centralized production system. Say for example, our previous example of a car manufacturer or manufacturers like Pepsi and so on. This centralized is still way much more smaller, but because my one unit shared by so many people, so I can still say production is centralized. Because production is centralized, transportation also becomes centralized. I have to lay down pipelines to transport the material. Usage is again happening in a distributed manner. Disposal is again centralized. Say in case I said that the biogas plant was not to be owned by a third party, but to be owned by the same community who is producing it, this story would have changed. Then this disposal might also become like everybody's responsibility. Then I can say that in that particular case, disposal becomes also distributed. Now, what does a network of networks mean? Say for example, I have a network over here, I have another network, I have another network, and these networks are connected to each other. The biogas units are connected. So, what I am not connecting is the line of so that line which is coming from the toilet of a particular house into the biogas unit. I am not connecting, I am not sharing that with these biogas plants, but what I am sharing here is excess biogas produced. So, if this network is not able to use the excess biogas produced and there is a shortage in this network, that excess can go over here. Again, you have to have more sophisticated metering and payment systems to run this kind of a network of networks. Obviously, this network of networks have higher sustainability potential. Why? Because of the whole point that in case of a shortage over here, it can be used over here. In case of one particular house, say for example, or say 3-4 houses in this area, there is nobody in that house. So, the production also goes down, plus consumption also of course goes down. But if the production goes down below the consumption levels of what are these other units require, this unit can satisfy it. So, people will have more reliance on the unit. They will know that they do not need to have a LPG connection at all. They can rely on this particular system. So, if we again look at this particular network of networks DE on the life cycle. So, pre-production is again happening in a distributed manner. My production is now decentralized. So, I have many different biogas units at which the production is happening. Transportation again becomes decentralized as a result of it. Usage is distributed and disposal also becomes decentralized. Not necessarily you have to do it in disposal decentralized. You can also think of a way in which you can make disposal distributed, or you can make disposal centralized also in this particular context. So, you have to consider what is the situation, what brings in highest level of socio-economic and environmental benefit, and then take up such a direction. Now, the last configuration is centralized connected DE. So, say for example, in this network of mine, you could see there is one restaurant. Of course, the production of raw material at a restaurant can be very high as compared to that at house levels, but the consumption of biogas at a restaurant is also very high. Say the restaurant knows that I cannot all my requirements cannot be fulfilled with this biogas unit, only say 50% of my requirement can be fulfilled. So, they will also have a connection from an LPG producer. So, in this case, this is a DE. So, it is a distributed economy, it is a network distributed economy which is connected to the centralized economy, because my LPG production happens in a centralized manner. So, centralized connected DE. Why the restaurant will still want to get connected to the biogas unit? Because still 50% of its energy requirements are being fulfilled in a more environment friendly manner, in a more sustainable manner, and it is also cheaper as compared to this centralized option. So, in this particular case, again pre-production is happening in a distributed manner. I am picking up here all the contexts which were from the network diagram. So, centralized production, centralized transportation, distributed use and centralized disposal. The only difference over here is coming is one particular entity or maybe more than one entity are connected to the centralized system. So, you can have different types of distributedness. So, you can have distributed energy generation, say for example, solar home based power generation at homes, or it can be also in companies. You can have distributed manufacturing. Say for example, whenever you do 3D printing, that is distributed manufacturing. The craft sector in India works in a distributed manufacturing, so every craftsman is a manufacturer. They do not belong to one organization under whom they are working as an employee. Then you can do distributed production of food. Say for example, in cities, if everybody is growing some kind of a food in their own home garden, that's an example of distributed production of food. Say for example, distributed water management. So say if you install a rainwater harvesting system in your home, you are doing distributed water management. You can also install a sewage water treatment unit in your house, and that can also become distributed water management. Distributed production of software. So say for example, Linux is an example of a software which is developed by many individuals. Distributed production of information or knowledge. Say for example, Wikipedia. Anybody and everybody can write a Wikipedia page with fill up with content and give references, and that's distributed production of information and knowledge. And the whole platform has become so huge now that for almost anything and everything that we want to know, we first try to find out whether there is a Wikipedia page for that, so that we can at a very quick glance get an overview of that topic. Then comes distributed design. So all sorts of open innovation, crowd design, they fall under this category. Say for example, you can look up, if you do not know what a OS vehicle is, you can look up online. It's a very interesting electric vehicle platform which has been again designed by, it's a crowd design. So designed by people, anybody and everybody can come and contribute towards the design. So these are certain examples and typologies. So in each of these typologies, certain activities can happen in a centralized manner or decentralized manner, and there are certain activities which are happening in a distributed manner. So the rationale is that beyond a limit, pollution prevention is not profitable or technologically possible for a large scale company. So we need to do a shift in economic thinking to understand how can we reconfigure the production chain. So not that distributedness is something new, distributedness has always existed. So if you see distributed water management, like having your own rainwater harvesting unit, or the craft sector which has existed since so long, where you do distributed manufacturing, or if you go to the rural pockets, people spin their own thread, then they also weave their own clothes. So that is also distributed manufacturing. So the producer of that cloth is the consumer of that cloth. So this distributedness is nothing new. What has become more new with the industrial revolution was shifting towards centralized economies. So that led to many environmental problems, economic unsustainability, social unsustainability resulting out of it. So the need to rethink our production chains. Why should it be that particular way, the centralized way, to be profitable? Not necessarily all activities, or not all production activities can be done profitably at a small scale. Say car manufacturing, it might not work in a distributed economy model, because you need huge setup to manufacture the vehicles. But many of our production processes can be rethought to see if they can fit into the distributed economy model. So one needs to question the structure and purpose of our production system and connect it back to the unit of satisfaction. So how distributed economy brings in sustainable development is through regional development. How? So there is reduction in extensive logistic activities like transportation, and just because you want to transport it over large distances, you have to do very robust packaging. So it can bring in reduction in transportation and packaging. Lot of energy can be saved, lot of fuel can be saved, lot of pollution can be prevented. Then customer and production are more connected. As a result, better satisfaction is possible. So if I am myself the producer of what I want to consume, I know what I require better than somebody who might be located thousands of miles away from me. So the chances that better satisfaction is possible because customer and production are more connected or are the same person is higher. If I am more satisfied, I might use that product for more longer time. Avoidance of activities like restructuring of manufacturing activities and outsourcing these to countries or regions with lower production costs. This can be also avoided. So, say for example, now when if I say that in my country production is becoming very expensive, switch it to country X. I am taking away jobs from my country. I am also I am just shifting pollution from happening in location A to location B, but globally we are all connected. So that particular strategy impoverizes the region where the factory was initially located, and it does not bring in any other improvement, any improvement in environmental aspects. Possibility of value creation connected with regions and culture. When activities used to naturally happen in a more distributed manner, we would always think of we would always connect a region with all the things that they manufacture. Say for example, Banarsi silk or sweet coming from Mathura. So we were always connected a region or a culture with the materials that they produced or the services that they produced, which is about social sustainability, cultural sustainability. So that can be brought in through this distributed economy. Possibility of using renewable energy, local material resources and manpower is also possible, because these are small production units. Renewable energy generated on site can satisfy their requirements rather than huge production units where the renewable energy generated on site cannot satisfy the requirements. Also, we will be able to use more local materials that will boost the local economy, local manpower usage, that will again further boost the socio-economic context of the region. The possibility to empower individuals and communities and reduce poverty and inequality is also provided by this opportunity. You have to be very careful. Distributed economy does not guarantee environmental sustainability. You have to build in environmental sustainability to get that. Similarly, distributed economy, although it has promising socio-economic benefits, but you have to build into it features of sustainability. So the research hypothesis of the Lens group is that if I use sustainable product service system design principles and apply it to distributed economy, I can get win-win sustainability for all. So say for example, the example that I spoke to you about MPower, the distributed renewable energy related company, they are offering an SPSS. So they take up this concept of distributed energy generation, that is solar power, and they are using an SPSS model. So they have married the two. So SPSS apply to distributed economy, and as a result, people who were not connected to the grid in Tanzania or for whom it was too expensive, they are getting the benefits of having electricity at home. So you are getting clean energy, you are having its socio-economic benefits. So that proves that SPSS applied to DE has a very good win-win possibility for sustainability. So you can use all the tools that we discussed for design for sustainable PSS and try to see, can you build it in a distributed economy. Now since you know what distributed economy is, and that can give result to more sustainable solution. In distributed economy, it does not need to be that distributedness has to be in each and every activity. Certain activities, say production or design, or energy generation can happen in a distributed manner. So we keep on uploading more and more about how to design for distributed economy, case studies, pedagogy material on our Lens India platform as well as the Lens International platform. So to know more about this particular area, you can log on to this particular website, and on this website, so you can see I have clicked on course. So you click on the course icon over here, so that this is highlighted. If not, and you scroll down to reach to this subsection which is called sustainable product service system and distributed economy, and then the next subsection which is called design SPSS applied to DE for all. So you can know more about this aspect. On this platform you can also search on distributed economy, and you will get to know more about this particular area. So in our next lecture we will be discussing about design for sustainability tools and approaches in the domain of architecture. So architecture is a very important domain. So as per a report, out of the entire global energy, 30 to 40% of the entire global energy is consumed by buildings. So you can imagine the impact of buildings on sustainability. Hence we will discuss about certain tools and approaches towards achieving sustainability in the area of architecture in the next lecture. Thank you.